All right, chapter 4. We're starting chapter 4 today, and what we're going to be looking at in chapter 4 is numeration systems. Numeration systems is how we do numbers, how we think about numbers, how we process through numbers. More specifically, we're looking at mathematical systems. So a mathematical system is made up of 3 components. A set of elements, right? So our elements are the digits 0 through 9. One or more operations for combining elements. So we have lots of things to combine elements. We have addition, subtraction, multiplication, division, as well as some other things that can operate on individual elements. And then one or more relations for comparing elements. So things like less than and greater than, equal to, not equal to, that stuff. So we're going to look at different systems from across history for today in sections 4.1 and then also in 4.2. We're actually going to start with our system, just reminding you what it's called, because you may not have ever seen it called this before. But the system that we use is actually called the Hindu-Arabic numeration system. Okay? So go ahead and fill in the rest of this first part, and I'll flip to the next slide so we can talk about our system. So our system, the Hindu-Arabic system, includes all 3 of these components, as I mentioned. We have the numerals, 0 through 9. Numerals are our single digits. Notice the numeral, or the value 10 is not a numeral, because it's 2 numerals, 1 and 0. Some of our operations, as I mentioned before, addition, subtraction, multiplication, and division. And some of our relations are equals, less than, greater than. And we have others in each of these categories as well. So our Hindu-Arabic numeration system that we use is a mathematical system. Okay, so the first old system that we're going to talk about is Egyptians. That's going back pretty far, right? It is. And the Egyptians have a system that's very, very simple. It's very simplistic. It's very easy to move between our system and their system, but it's kind of bulky and cumbersome. So let me show you what their symbols look like. So the Egyptians have symbols for the numbers 1 to 1 million, but only in the ones, like only the value 1. So we've got the value for 1 and for 10 and for 100, right? So like the powers of 10 that we would use. The descriptions on the right-hand side of the screen give you some kind of an idea of what the item is going to look like, okay? So I'm not asking you to memorize these. You'll be able to use them on your quizzes and on your tests, but you definitely want to have this table accessible so that you know how to go in between. The value for 1 is a stroke, and it's simply looks like a tally mark, or like our number 1. So that one's easy. The second one, for the number 10, looks like a symbol we've seen before in another context. It's called heel bone, and it actually looks like the symbol that we used for intersection. It's an upside down U. The third one, for the number 100, is called a scroll, and it kind of looks... It's not great. That's pretty good. Kind of looks like a 9, but with a curly inside of it or something. Okay? And I will say too, interestingly enough, the symbols themselves were this is kind of like our symbols. You know how we use the number 4 and we write things like this, and we also write like this? You'll know what I'm talking about, depending on the typesetting and things that you use or how you write your numbers. There's a little bit of that going on with their system as well. I'm going to do the ones that are going to show up inside of my math lab, inside of this textbook, but I use another textbook and the symbols are slightly different. So just kind of throwing that out there is that this is not a standardized, always it looked exactly like this kind of thing. The number 1,000 is where the symbols start to get more complicated to draw. You're not going to be drawing, then you're going to be selecting them from like multiple choice settings and things like that. But it's called the Lotus Flower, and it looks something like this. I make no claims to be any kind of artist. So if you're looking at this and then you look at my math lab later and say, well, she didn't draw it very well, I warned you. All right, the next one for the number 10,000 is a pointing finger, and you might think that I could draw this one better than the Lotus Flower, and you would be wrong. But it looks something like this. And it really does look something like that, actually. It's a very strange looking symbol. The next one, it depends on the resource you use. Our book calls it a Burbo Fish. I've also heard or seen resources call it a whale. And this one is another one that it looks a little bit different depending on the book that you use. But it looks, or a tadpole, I've seen it called a tadpole in one of the resources I've used over time. It looks like this. It's a smiling fish. Okay? And the last one, worth $1 million, is an astonished person. And obviously he's astonished if he's worth $1 million, right? You bet. Again, this is a different looking symbol depending on the resource you use. And so we'll use the symbol that our book uses, which looks something like this. Excited. Those of you who might be education majors, when you take the class called Number Theory, we go through this again, and you'll see the symbols change if that's you. And in particular, the astonished person doesn't look like this guy at all. He looks quite different. The others are quite similar, but this one's quite different. Okay, everybody good? Got them all written down. So what we're going to do first is we're going to take one of their numbers, and we're going to figure out what number it represents in our system. So we have these symbols showing up, okay? So we have the pointing finger, we have 2 lotus flowers, we have 2 of the heel bones, and then we have 3 of the strokes. And we're just going to see repetition of symbols for repetition of value. For example, at the end, when you see the 3 strokes, let me get my white pen up. The 3 strokes here, they each stand for the number 1, so this is the number 3 at the end, right? Just repeat the symbol for the repetition. The pointing finger, how much is he worth? 10,000. So this is 10,000, and there's only one of them. There are 2 lotus flowers. How much is a lotus flower worth? 1,000. So since there's 2 of them, it's 2,000. And then my heel bones. How much are my heel bones worth? 10, and there's 2 of them, so it's worth 20. Okay, is that all right? So that's what they're individually worth, and then we just combine them all together. So this is the number 10,223. So 12,000. I didn't say that right. 10,000, then 2,000, so 12,000. Yeah. It's 12,023. Now, do you need to worry about writing all these pieces out? No, I'm going to show it just to make sure everybody's seeing where all the pieces are coming from, but if you can jump straight from the symbol to the end, that's cool. When you see them in your My Math Lab, this is a really good section where partial credit shows up a lot in your quizzes and your tests, because let's say, for instance, you accidentally looked at the heel bone and thought that you were in the hundreds place, and you wrote down 200. And so instead of your answer saying 12,023, it said 12,203, like this. Well, you knew most of it, right? Like if that's what you wrote down, I mean, My Math Lab is going to count you wrong. I mean, because you're going to type that in. But I'm going to look at it on a quiz or on a test, and I'm going to say, oh, look, all they did was they forgot, and you're going to get like 75% of the credit. So you see partial credit having a lot in the side of this section. When we go the other direction in a moment, where we're given our number and we're turning it into their number, those show up as multiple choice because they don't have the capability for you to draw or like to drag symbols in and create the numbers themselves. So those will show up as multiple choice. All right, let's take a look at number 2. The fish. How much are the Burbo fish worth? Yeah, 100,000, right? So I have 3 of them, so it's 300,000. All right, I have my scrolls. How much are scrolls worth? That is 100, and there are again 3 of them, so I have 300. I have heel bones. Heel bones are worth 10, and so this is 40, right? And then the last one is my strokes, and my strokes will give me 2. So this number is 300,342. Yes?
So how do we, is it after the 4 that they begin to be stacked?
Oh, that's a good question. So it's not something that's going to cause you any problems because they're going to stack them or they're not going to, but you do usually see them when they come to having 4. So yeah, so when there are 4 symbols, sometimes you don't see it with the strokes stacked that many because strokes are just so nice and compact anyway. But yeah, you will see them start to be stacked when you get to 4 symbols, typically speaking. But it shouldn't cause you any trouble because of the way that that's presented in my math lab. It'll be there or it won't. Yeah. Any other questions? Okay, so we're going to convert the other direction now. So we're going to start with a number in our system, and we're going to draw the symbols that correspond to it in their system. And we're going to start with the number 23,145. So the 2 is in the 10,000s place. So the 10,000 is represented by what symbol?
Pointing finger.
The pointing finger. So the 2 says that I need 2 pointing fingers. So I'm going to draw 2 pointing fingers. The 3 is in the thousands place. What was the thousands place? Lotus flower. We haven't drawn him or seen him much since I mentioned it. So I need how many lotus flowers? 3. My symbols start to look worse over time. All right, my next one is a 1 in the hundreds place. It's a scroll. I have a 4 in the tens place. 40. So the 40 would be the 4 heel bones, right? And we will stack them up. If you didn't stack them up, you're looking for multiple choice anyway. You'll figure it out. But there's 4 heel bones. And then I have 5 strokes. And we'll stack them something like that. But if you wrote them all side by side, it'd be fine. Okay. So far, so good? All right, so we're going to do one more here, but let me just pause for a second and let's talk about it. Is it pretty easy to go back and forth? I think it's pretty easy to go back and forth. The symbols kind of flop back and forth pretty nicely. But can you see how this might not be the most, like time-efficient way of doing your numbers? What if your number was 99,999? That's not going to be good, right? You're going to have to draw 9 symbols for every single one of them, for 5. That would be it'd be messy, it'd be long, it would be very time consuming. So there are some positives. It's very nice to move in and out. There are some negatives. It can be time consuming if the numbers are large. All right, we have another one. We have 51,300. So the 5 is pointing fingers. We have 5 pointing fingers. That. How about the 1? Yep, the flower. So we have 1 flower. And the 3? Yep, 3 scrolls. Just like that. Any questions? Okay, of all of our systems, this is the only system where we're about to do the following. We're going to do some addition and subtraction inside of their system. So the goal is not to take the numbers that they give us on this next screen. here, I'll flip back to adding. The goal is not to take these, to turn them into, the Hindu Arabic system that you know, to do the subtraction, then turn it back. That's not the goal, all right? So what we're actually going to do is it's going to look very much like our system, but we're going to stick with their numerals. So the adding of Egyptian numerals is much like ours. We line up the same symbols, like we would line up the same place values. Sometimes we need to carry through regrouping, and we work from right to left. Okay, so it's going to feel a little bit like a puzzle or a game because it is so similar to ours. It just uses symbols that are different than ours. So the carrying regrouping, if you think about our number system, the way that this works is if you have like a single digit, we'll use the units place, that adds up to more than 10, right? So like you have an 8 plus a 4, and it adds up to 12. We write the 2 down and we carry, or we regroup the 1 from the 12, right? So we don't exceed 10, we actually don't exceed 9 in any place value before we regroup it to the next value. It's going to work similarly for this one. It's just going to look instead like I'm changing the symbol instead of changing it to the next place value. So we have this bunch of symbols. Again, the goal is not to just rewrite them into our symbols. If you take a look, we're going to work, again, like I said, from right to left. So on the right-hand side, how many strokes do we have? There's 6 strokes, right? 2 on top, 4 on bottom. So that's 6 strokes. I just write down 6 strokes. 1, 2, 3, 4, 5, 6. No problem. How many heel bones do I have? Altogether. Is it 11? Okay. So for the moment, let me just write the 11 down so I can show you what we're going to do with them. We'll put one more here. So there's 6, 7, 8, 9, 10, 11. And then how many scrolls do I have? 1. All right, this is not my final answer, though, because I have too many heel bones for actually what it is. It's almost like somebody gave you 11 $10 bills. Imagine for a minute, 11 $10 bills. Well, you could take 10 of them and turn it into what? A 100. It's the same thing we're going to do here. We're going to take 10 of these and we're going to turn it into a 100, and a 100 is a scroll. So what I actually end up having is 2 scrolls, 1 heel bone, and 6 strokes. So again, inside of my math lab, what will it do? Well, it'll want you to pick this answer in a multiple choice form, and then it's going to want you to write the corresponding Hindu Arabic numeral to that value. So what Hindu Arabic numeral does this represent? Yeah, 216. So it's both of these things that end up being the answer to the question that's posed. Okay? All right. That's addition. We're also going to do subtraction. So again, if addition's similar to ours, you think that subtraction would be, and it is, much like ours. And we use regrouping, otherwise known as borrowing, when necessary. So we should do one, right? Of course. This is our one. Okay, just like with us, we're starting with the ones place. That's the strokes place. On the far right, there are how many strokes in the top number?
7.
There are 7, and how many are in the bottom number? 3. So if I have 7 strokes and I take away 3, how many strokes will I have? 4 strokes. So I'll just write them all beside each other. But if you want to stack them, you could. 4 strokes. All right. But there's a problem when we get to the heel bones, right? There's 3 heel bones on top, and how many are there on bottom? 7. Well, I can't have 3 minus 7, just like if you were doing mathematics, in Hindu Arabic, we don't do 3 minus 7. We regroup or we borrow from the next place value over. Well, for us, we're regrouping or we're borrowing from the scroll's place. So we're going to take a scroll away, and it's going to turn into how many heel bones? 10. Yeah, a scroll's worth 100. A heel bone's worth 10. So there are 10 heel bones in a scroll. So we're going to have 10. There's 10 heel bones that are now inside of this category. So now up here I actually have 13 heel bones. So I can take away the 7 heel bones from it, right? 13 heel bones minus 7 heel bones gives me 6 heel bones. So I have 6 down here. Now looking at my scrolls, I still have enough, right? I have 4 on top. I've eliminated 1 of the 5, but there's still 4 there. I have 4 scrolls minus true scrolls gives me 2 scrolls. And my lovely Lotus Flower doesn't have any subtraction, so it just comes down. This is one of those places where you want to be careful, right? In our system, if we were missing a digit, we would have like a 0 column, right? There's no 0 columns here, so you don't want to just necessarily assume that this is a 4-digit number in our system. It doesn't always work that way. This one is, but it could have skipped over one of the pieces as well. So the Lotus Flower is worth 1,000. The strokes that I have here, I'm sorry, not strokes, the scrolls that I have here are 200. The heel bones are 60, and then I have 4 strokes. So this is 1,264. And these are both the pieces that show up as the answers to the question. You ready to switch systems? Okay, the Egyptians is the easiest one to work with. Please remember, I warned you, okay? But the next one you're familiar with. I know some of you have notes. What's the next one? Roman numerals. You're familiar with Roman numerals. Where have you seen Roman numerals used? Page numbers, books. Super Bowl. Anything else?
Movies.
Movies sometimes. They will, yeah. Another place, if you ever have the opportunity to visit the East Coast, is that the East Coast is old enough, like buildings and stuff, that you will sometimes see buildings and or tombstones dated in Roman numerals. And the reason I know is because I have a brother-in-law who actually got married in Virginia. And he got married in, I think it's the church that Thomas Jefferson is buried in their graveyard outside or something. Something like that. Just something like that. And on the building and on the gravestones, it all had Roman numerals. Because it's old over there, right? Oklahoma's young by comparison. We don't have that here. But Roman numerals show up in lots of places. There's one that you haven't mentioned, though. Math, sure. You're right. Time. Say like on clocks. Yeah? You walk past one every day, right? Rayleigh Chapel has a clock that has Roman numerals on it. So you do see them on clock faces sometimes too. If you know how to tell time. I hope you do. My children definitely need digital clocks. Anyway, all right. Some symbols. All right, so you know some of these. Some of them you probably don't know because they do get large. But the symbol for the number 1 is an I. And depending on it, it might actually have the top and bottom on the I, or they might just write it as an I like that, right? Either of these are fine. How about the 5? The, again, it might have tops or bottoms on things. I'm not going to keep writing them, but they do show up there sometimes. How about the 10? X. Because people are usually good at that point. What happens when you get to 50? L. That one's shown up fairly recently on Super Bowl stuff, so maybe you saw it there. What happens after that? Let's see, we have 100. It is C. We'll get to the M in a minute. 500? is D, which must mean that 1,000 is the M, yeah. Okay. So there's actually several sort of issues inside of the Roman numeral system to be aware of. I think I have a slide for it, or do I write it on this slide? Yep, I do. Okay. So they have some different things. They have repetition of symbols, like the Egyptians did, but they don't repeat the symbols as many times, right? Like I mentioned, 99,999 being unhelpful to write in Egyptian. It would not be near as bad in the Roman numeral system, because they don't write things out 9 times. Part of the reason for that is because they have these symbols for 5 and 50 and 500. Another reason is because that they stop repeating things with 3 digits. So the first issue is repetition of symbols. So they have a subtraction process. So if there's a symbol that they would have had to write 4 times, like the number 4, they don't write 4. They write IV. Okay, so if the smaller digit comes before a larger digit, it is subtracted. So I before V is going to be 4, but if you had the V and then the I, it'd be 6. So anytime the smaller symbol comes before the larger symbol, we subtract. They only do it for symbols that are 4s and 9s. So you're not going to do that if you have an 8 or if you have a 3 in any place value. Only 4s and 9s. And so since it works for the I's and the V's, it also works for X's and C's or L's. So if you have the number 40, then XL, because it's a 10 before a 50, is the number 40. And XC, because it's a 10 before a 100, is the number 90. And then we have the thousands place, the 500 and the thousands. So if you have 400, a C before a D would be 100 before a 500, giving you 400. And a C before an M would be 100 before 1,000, giving you 900. This is probably, of the 2 properties, we're about to see the other property, the property that you're at least somewhat familiar with. You've seen it before with the number 4, right? IV, you've seen that. You've probably seen it before with the number 9, IX. Maybe not so much with the bigger values, but they work the same way. The second feature that they have comes about because you might have noticed the number 1,000 is not a very large number. What do they do if the number is bigger, right? The Egyptians could go all the way to 1,000,000. The Romans seem to be stuck with the symbols they're using at the number 1,000. So they have a multiplication feature. If you have a single bar above values, it means times 1,000. Okay, that gets you numbers up to 1,000,000. Actually gets you numbers up to 3,000,000. And if they do a double bar above things, it's multiplied by 1,000,000. Promise we'll do examples, but those are the 2 features that allow their system to create compactness, right? Fewer symbols, not as much repetition, getting larger values. All those kinds of things are able to be achieved by these 2 properties. I think everybody's pretty close. So we're going to do a couple of examples, kind of like what we did with the Egyptians, where we take their symbol and we turn it into ours. And then we're going to do a couple of examples where we take our numbers and we turn it into theirs. So much like I did with the Egyptians, we're going to write the value that's represented underneath each value, which will also help us to see places where we use that subtraction feature and places where we might have the multiplication features going on, like with number 8. So we'll start with the M. How much is M worth? It's worth 1,000. How much is the D worth? 500. How much is X? 10. C. How much? 100, sorry. The V, 5, and then the 2 I's at the end is 2. Okay, everybody good so far? So what we're looking for, we're not just going to add them all together. We're looking for any place where we see a smaller value before a larger one. And do you see any of that happening? Yeah, which one? Yep, the XC. The 10 that comes before the 100, that's a subtraction feature. So I don't have 10 and I have 100. What do I have? 90. So this place gives me a 90. Everything else has larger before smaller, correct? So everything else will be added. So now I will have 1,000, I will have a 500, I will have a 90, and I will have a 5, and I will have a 2. And you can literally add them all together. Many of them are place value specific, so you don't have to do much. You're just writing each of the individual place values down. But some are. So I have the 1,000, I have a 500, and I have a 90, but then the 5 and the 2 at the end, of course I don't write 5, 2. I add 5 and 2, which gives me 7. 1,597. That could be a date on a building in Virginia. It could. The next one could not. Okay. Do you see those bars on top of things? Okay, so we need to be careful when we're looking at the bars on top of things. Well, we're going to write down our numbers just like I did before, but we need to pay attention to the fact that some of them have bars on top. So the X, how much is X worth? 10, but it's 10 times what? A million. I'm just going to write a million underneath it to remind ourselves that we're going to have to take that into account. How about the C? It's 100. A D? 500. And these two have a single bar on top of them. So the single bar would be multiplying them by 1,000. So we'll come back to that. L, 50. X, 10. I, 1, and V. Good grief. 5. Okay, cool. Places where we see subtraction property. Let's deal with that now. CD. So I have 100, then 500. So this 100, 500 is actually the number 400. Any others? Yep, the IV at the end, the 1, 5. So it's not 1, 5, it's actually the number 4. All right, so we could actually write this out, again, with multiplication and addition features if you wish. We're going to take 10 times a million. We're going to take 400 times 1,000. And then I'm going to have 50 plus 10 plus 4. So 10 times a million is actually 10 million. 400 times 1,000 is 400,000. I'm about to show you something else kind of cool in just a sec. And then what about my 50, my 10, and my 4? Yeah, it's 64. Right? 50 and 10 is 60 plus my 4 about 64. Oops, I left out a 0. So sorry. 0, 64. Okay, notice this, though. The 10 is separated from a comma from the rest of it. And the 400 is separated from a comma from the rest of it. Do you see how it lines up so nicely? It does, and it always works that way. So those bars on top separate it into the different place values that we separate with commas. Okay? I think this direction is the easier direction to go with Roman numerals than the other one, at least when we have the bars going on. So let's try going the other direction now. So, I should also mention the bars, are only used when I have no ability to do something. So like on this one, do you see how I have a 2 in the thousands place? I can do 2,000. How can I do 2,000 without any bars? MM. So I will do 2,000 with the MM. I will not do the number 2 with the bar on top. That's not how it works. The bars only come into play when they're necessary, and they're not necessary here. So the 2 is MM. Okay, how do I get 800?
These with 3 C's.
Okay, So 800, it's not a 4 or 9, right? So I'm going to be doing an addition feature. I can get 500 by doing a D. And then I can get the other 300 by doing 3 C's. That's 800. How do I get the 60? I'm going to have an X. LX. So the 50 first, and then the 10 afterwards. That's 60. If I flipped them, I'd get 40, right? Yeah. XL would be 40. LX is 60. And then I get the number 1 with an I. That one was kind of nice because it didn't have any 4s or 9s. Yeah? Got some 9s in the next one. Have to throw them in there, right? All right. The 7 million, however, is too big. I do not do 7 repeated, M's. Like, that's not a thing. If I need more than 3 M's, I have to use the bars. Everybody understand that? So it's breaking this apart very much right here, where I have to do the number 7. So what's the number 7? Just the number 7. VII. This is the number 7. How do I make it 7 million? I do a line over it. Just one line? 2 lines. Yeah. 7 million would have 2 lines on top of it. Okay, does that make sense for everyone? Okay. 300,000. That's what's next. Again, that's too many, right? 300,000. I can only go up to 1,000. I can't do anything multiple times to get 300,000. But I can get 300. How do I get 300? 3 C's. And how do I make it 300,000? Bar on top. Okay, does everybody see how those pieces are coming about? Great. 999. Well, you have, this list of things you wrote down, right? Of how to get 900, how to get 90, and how to get 9. How do you get 900? You do a C and then M. That's 900. How do you get 90? An X and then a C. And how do you get 9? I and X. What I want to point out right here is that it would be very friendly if they had said, hey, look, 999 is just 1 short of 1,000. I should be able to do IM. They do not do that in their system. Okay? So as much as we wish they did it in their system and we'd like to sort of adjust their system, they're not around anymore to adjust, right? We have to go with what they did, and this is what they did. They separated each of the 900, the 90, and the 9 in this fashion. Okay? So this is where we end up. And I contend that's kind of bulky. It's kind of messy looking. It's kind of ugly. But it might not be quite as long as if I had to write out 999 in the Egyptian system. Okay. One more system in 4.1. You ready? Okay. Chinese. This is the first one you've probably had absolutely 0 encounters with, right? It'll be okay. All right, so there are notes on the side. We'll just read through those first, and then I'll show you what their symbols are. The traditional Chinese numeration system uses positional numeration. That's what we've actually already seen. But it has a multiplicative grouping manner. That's different. The other thing that's different is they don't write it from left to right. They write it from bottom to top. This is written vertically. So the numbers in traditional Chinese go like this. Now this is the only one, too, that the people group that created this is still around, right? We don't have the Roman Empire anymore. We don't have the Egyptians around anymore. So every now and then somebody asks me, well, do they still use this? And they do in some of their things. So I actually had a student from China in my class one time and was talking to me a little bit about that. So they do see this used, but they don't do mathematics with these numeration systems. The Hindu numeration system that we use is rather universal in terms of cross-cultural and things like that. But these are used sometimes in literature, kind of like you see Roman numerals used in literature, with, section numbers and things like that. Okay, so we're going to write out the symbols. So the first symbol, just looks like a little bit of a horizontal line or like a dash. The second one looks like two dashes, but the top one's a little bit smaller. And the first one almost looks like you're about to do something in penmanship, right? With the lines in the middle. Those are the only three that have that sort of like I can count them. It's one line, it's two lines, it's three lines. Everything after that's going to be different. But those are pretty straightforward. And you can see how writing those from left to right would look weird, but stacking them on top of each other might sort of make sense, right? Because of the way that they're drawn. The next one looks like this. I think it looks like curtains. The number 5 looks like an H or like a chair a little bit. It's got a small line on top and a larger line on bottom. The number 6, I think he looks like a stick man. Seven looks like a lazy T. The number 8 actually looks like a Greek letter. Does anybody know what Greek letter that looks like? Lambda. Yeah. 9 might be my favorite because it looks like an N. N for 9. That's a good one, right? You can do that one. 10 looks like a plus sign. $100 actually looks like, I think it looks like Wile E. Coyote and Roadrunner, like a TNT bomb. That's what I think it looks like. Yeah. It should be a little bit more centered than the way I've drawn it. No, I can't fix it now. We're just going to leave it. It's fine. The number 1,000. The number 1,000 looks like that same plus sign, but it's got an extra little line on top of it for 1,000. But the number for 0 is going to be your least favorite. Are you ready? Okay. I don't have any descriptors for it, so we're just going to draw it. I can't even draw it well enough. I need to do it bigger. Let me do it a little bit bigger. Okay, so it looks like this. It's got 3 lines right here. And it looks like there's like a little P underneath it. That's awesome, right? I mean, let's be real.
Looks like some sort of cliff.
Like a cliff?
A glyph.
Oh, yeah, it does. Okay, here's something really important to notice. These symbols down here at the bottom, the 10 through 100 or 1,000 symbols, these symbols are actually used for the positional part of their system. Okay, so I'll show you what I mean by that. But they're not used independently like the number 10 and the Egyptian symbol was the scroll, and we just wrote it a bunch of times. That's not how they're used at all, okay? The number 0, you might look and think about this. This is the first time we've seen a 0 show up. Neither of the other systems that we worked in had a 0, and that causes problems. In fact, you're going to see how it causes problems in my next system that I show you. But this one has a 0 symbol, and that's nice. Okay, so just like with the other two systems, we're going to start with the Chinese symbol and turn it into ours. So let me show you how that positional multiplication works. So I'm just going to pause real quick and let you write them down, because it's going to be a lot of up and down trying to get those symbols on there right. I'm missing them down at the bottom, so. So we're going to do the same thing we did with the other systems. We're going to write the value that the symbol represents next to it. Okay? So the n is 9. So this is a 9. The TNT bomb is 100. The 3 lines is a 3. The plus sign is a 10. And the H is a 5. Okay, everybody good so far? Okay. What you will see happening in their system is they line up so that these two, it's a 9 and a 100. And then there's a 3 and a 10. And it's telling you the 9 is multiplied by 100, kind of like the bars on top of things in the Roman numeral system did, right? You're multiplying it by that value. So this is 900, and then it's 3 times 10 or 30, and then you have 5. So what number do we have here? 935. It's not that bad. Okay, the symbols are a little wonky on a couple of them, but it's not that bad. Okay, let's do the same thing for the next one, the curtain. 4. The plus sign with a little bar on the top. It's 1,000. 2 lines. A 2. And my TNT box. 100. So this is 4,000. And then 200. Okay. Again, I think it's easier to move from their system into ours. Going the other direction is a little messier, but we can do it. So let's give that a try. Does everybody have those two written down? All good? Lovely. So we're going to do the number 202. Okay. So I start with the 200, the first 2 in the 200, 2. And so how do we get the number 2? 2 lines. But I need it to be in the hundreds place, so I have to multiply it by the 100 symbol, so the 100 symbol goes underneath. So the 100 symbol looks like the TNT box. The 0 here that's happening since it's in between numbers, notice there weren't any zeros showing up at the end of the 4200. But the zeros, when they're in between, like sandwiched in between numbers, is when that 0 symbol shows up. So I need to draw that 0 symbol that was our favorite, right? It looks like that. All good? But it's in the what place? Oh, it's in the tens place. Right? 0 times 10. And then I have the 2 at the end, which is another 2 lines. Fun times. All right, the next one does not have a 0 in it. We all said thank you, right? Yeah. All right, 7. What do I do for the number 7? It's the lazy T. But it's in the thousands place, so plus sign with the line on top. It's not very good. There we go. Let's see, I have 600. What's the 6? It's my stick man. In the hundreds place, so it gets the TNT box underneath. We have the number 1, and so this is where it feels a little bit tricky. It feels like, okay, but it's just a 10. Can I just put a 10 in? And the answer is no. We have to first put the 1. So 1 is the bar, the straight line, right? And then I have to say that it's times 10, which would be the plus sign. And the last number is a 2, so I have 2 lines.